Welcome to Math 1960 Calculus 2. This is UNO summer session. Today we will discuss about improper integrals. So improper integrals is any integration that looks like this. When you have infinite limits in the integration, such as negative infinity up to a of f of x dx, this is known as improper integral. This is different from the integration that you know, which has real limits. Also, if you have integration that looks like so, the limit from a to infinity of f of x dx, this is also known as improper integral. Also, if you have integration from negative 3 up to 3 of 1 over x dx, this is also an improper integral because within the range there is a point at which the integration is undefined. So this would be point of 0. So improper integration is a well-known techniques to tackle these type of problems. Okay, so here we are going to determine whether an integral converges or diverges. An integral converges when we perform the integration and we come up with a real number. We call that integration a convergent integration. But if we integrate a problem and then we come up with infinite number, or we don't find the integration does not exist, at that time we say this is a divergent integration. So let's first attack problem number 1. I have integral from 1 to positive infinity 1 over x dx. Now I'm going to change the limit of my integration that make it possible for me to integrate. So I'm going to say limit as b goes to positive infinity. So my limit now is going to be from 1 to b. I'm going to integrate the same function 1 over x dx. So then limit as b goes to positive infinity. So when I take the limit here, I'm going to get ln of x. So I'm going to evaluate from b to 1. So then now I'm going to say limit as b goes to infinity of ln b minus ln 1. ln 1 is going to be equal to 0. So then I have limit b goes to infinity ln of b. So ln of b as b goes to positive infinity equal to infinity. So that means this function here diverges. Okay. In problem number 2, or part 2 of problem number 1, we want to find the integral of e to the x dx when the limit is between negative infinity to 0. So we do the same technique. We're going to change the limit of our integration So here we say limit as a goes to negative infinity, integral from a to 0 of e to the x dx. So limit as a goes to negative infinity of e to the x, a and 0. So then limit as a goes to negative infinity. So we're going to substitute for 0. So e to the 0 is going to be equal to 1. E to the a is going to be e to the a. So when we take the limit of these expression, we get 1. That means my integration converges to a certain number 1. Okay, so here we're going to do the third part, pi up to positive infinity of sine x dx. So at this point we're going to say limit as b goes to positive infinity, pi over 2 to b sine x dx. So limit as b goes to positive infinity. So when we take the integration of sine, we get negative cosine x. We evaluate that at pi over 2 to b. So that would be equal to negative cosine b, because cosine pi over 2 is equal to 0. So then when we take the limit of that, limit does not exist, because cosine function is going to change between positive and negative 1, and it will never go to a certain number. Okay, in this problem we're going to determine whether integration from negative infinity to positive infinity of 4x cubed dx converges or diverges. So this integration, we can actually say we integrate from negative infinity to 0 that function dx, plus integration from 0 to positive infinity 4x cubed dx. So when we take the integration of this one here, we're going to say limit as x goes to as a goes to negative infinity. So if one of them converges, that means the whole problem converges. Well, if one of them diverges, that means the whole problem diverges. They have to converge both of these sides. So let's take one at a time. If we find one of them diverges, that means the other one would also diverge. So limit as a goes to negative infinity of a up to 0 of 4x cubed dx, limit as a goes to negative infinity of this one here, that would be equals to 4x to the 4th over 4, a is 0, limit so that would be equal to limit of as a goes to negative infinity of 0 minus a to the 4th and that would be equal to negative infinity. So that means since this one here diverges, this also has to diverge. So the whole problem here diverges. It does not converge. So problem number 3, we want to determine if the area under the graph y is equal to 1 over the square root of x from 0 to 4 is defined. So we do the integral to find the area under the curve. So at this point we say area under the curve from 0 up to 4 of 1 over square root of x dx. So we're going to take limit as t goes to 0 from the right. So here integral from 0 to 4 of x raised to the power of 1/2 or negative 1/2 dx. So then we add 1 here, and then we divide by the result. So when we add, it's going to be x raised to the power of 1/2 divided by 1/2. So integral from here the integral is going to be from t to 4, from t to 4. Here time limit as t goes to positive 0. So then we're going to get limit as t goes to 0 from this side. So when we do this, it's going to be equals to 4 minus 2t. So when we take the limit as t goes to 0, we're going to get 4. So that means the area is defined to be 4. So in our last problem, we want to determine the integral from 0 to 2 of 1 over x minus 1 squared dx. We want to know whether it converges or diverges. So here we have integral from 0. This integration we're going to do it in, we're going to partition it from 0 to 1 of 1 over x minus 1 squared plus 1 to 2 of 1 over x minus 1 squared dx. So here we say limit as t goes to 0 from the right, integral from t to 1 of 1 over 1 minus x squared dx plus integral, we want to take eraser, we want to erase this. Okay, so from t all the way to 2 of 1 over x minus 1 squared dx. So here